one of the key properties that we consider when we're taking on new projects related to designing the balloons, picking materials, is how to optimize the final balloon as it relates to the design related to profile and potentially rewrap of the balloon. And rewrap for us is really easy. The key is to pick a material that has multi-layers in the initial balloon extrusion, and those multi-layers may have layers that are more thermally acceptable versus layers that are more strength acceptable. So multi-layers, whether it's 2, 3, 4, 5, however many layers are in there, if you can develop layers that allow you to optimize the heat from pleating, you're going to be able to have a balloon that has minimal profile and the potential for consistent rewrap after expansion, whether it's stent deployment or it's just balloon expansion. And the other key piece is related to the selection and the design of the tail dimensions, because there's limitations as to how small we can make a tail on a given balloon diameter. If it's a 27 millimeter balloon, we have certain limitations to the tail. If it's a 3.5 millimeter balloon, we have limitations, but we're going to get a much smaller tail. So tail dimensions as it relates to not just the balloon design, but also the attachment to the shafts, whether we're laser bonding or split die bonding or however we're attaching that balloon. So those parameters are critical in the early stage design. That's going to give the folding equipment the greatest probability of success when it relates to folded balloon profile and the potential for rewrap. And the rewrap is 100% related to our ability to deliver multiple layers and having a single layer in there that is accepting of the heat that you're going to create in the memory.
Yeah, and I think critical dimension of that is that, like you said, the working diameter of the balloon down to that tail diameter. If you can ensure that your tapers aren't going to have thick spots in them, that's a challenge that we see a lot of times. Is it's not necessarily the working length of the balloon that's creating that major OD. It's the tails or the tapers.
Right.
Where you don't have that material pulled or stretched to the right thickness.
And it's the mechanics of the blow molding process. Right. That allow us to move that material where it needs to go. And the more abrupt the taper, the harder it is to get the profile. The more gradual the taper, the easier it is to get the lower profile. So I think those are key design parameters that are critical to the downstream folding process. And a lot of times we're at the mercy of that customer's intuition as it relates to what they think that balloon needs to do in their clinical application, and the process equipment has to adapt. Mm-hmm. And we do everything we can at the design process to address the things that we know are going to be critical to the folded balloon profile. But a lot of times there's just a customer that is just absolutely hell-bent on a 90-degree abrupt taper, and ultimately that 90-degree abrupt taper is going to see issues as it comes to folding.
Certainly, yeah. It tends to fold upon itself rather than laying down in a nice manner.
And we've sat in the lab and seen this happen on large diameter balloons, and it's mechanically understandable. But I think when an engineer is on a SolidWorks screen and he's designing his balloon, he wants to optimize it for that specific application, and that doesn't always align with the ultimate process of folding, which ultimately starts with the design of the balloon, which includes the tapers, the tails, the working length, and then that starting extrusion, which if you can start with a multi-layer that has a thermally acceptable material in it, like a low durometer P-BAX or urethane, you're going to get a balloon that has a tendency to be low profile, thin-walled, high strength, and have some consistency related to rewrap. That's for you, Danny.